Huh? Same one. I'll use the same one for each unit, and then at the end of the unit, I'll switch over. So everything from rational functions will be in one place.
The more homework you have questions about, the less you have to do in class. I would ask about as many as she'll let you.
Not, oh, they've had me before. But that's also the less time they have to do their homework.
Well, we do that in calculus. We spent like whole days on homework.
Calculus. All right. Which one did you say? 7? 5. All right, let's do 5 first.
There's so many people that actually log on to the Miro board in this class. It's nice when people are like scared. How do you do this?
All right, here we go. Let me reel you in, boys and girls. We're going to start with factoring. We're going to factor everything that we can first, yes? Yes.
What's everyone's favorite?
So, Logan, go home. What multiplies to negative 12w squared but adds to negative 11w? Negative 12 and 1. Now, can I shortcut this? No, why? There's a coefficient in front, right? There's a leading coefficient, so I cannot shortcut it. So I have 4w squared minus 12w plus w minus 3 slash. Take out 4w, what's left? 1. Hold the place with the 1, then I got w minus 3. All right, so all I've done is the top of the first fraction now, right? Just factoring. So I've got w minus 3 times 4w plus 1. Now look at the bottom of the first fraction. What do you notice? Difference of squares. 4w minus 1, 4w plus 1. Times. How about the top of the second fraction? GCF? Take out a 2. What's left? 4w minus 1. And then the bottom of the second, difference of squares, right? So 3 minus w and 3 plus w. Question so far. All I did was factor. What you got, Will? You sure? The bottom of this fraction, is that the one you're looking at? So it was just the difference of 2 squares. It just was, instead of being written like this, the 9 came first. As long as they're both perfect squares, it doesn't matter which one comes first, as long as you're subtracting and they're both perfect squares. So I just did the square root of each one with a plus and one with a minus. All right, now because I'm multiplying, when I multiply fractions, I multiply straight across, top times top, bottom times bottom. So I just usually make this one big fraction instead of rewriting everything. All of my pluses and minuses are in parentheses, yes? That's how I know I can start striking out, okay? W minus 3, I don't have. We'll talk about that in a minute. 4w plus 1, 4w minus 1. So, that's right. So let's look. Let me rewrite it here so you can really see. I've got w minus 3, 3 minus w, and 3 plus w. Looks like something should cancel, right? Oh. Okay. Negative 1, that's exactly right. Because these are exactly the same other than their sign, right? W is positive, W is negative. 3 is negative, 3 is positive. I can cross them out, but put a negative in place. Nope. Doesn't matter. You can put it in front of the fraction. You can put it in front of the top. You can put it in front of the bottom. It doesn't matter. Just don't put 2. Don't do top and bottom. Just do it one place. Yep. As long as every sign is opposite. Yep. I will. I have it there, but it's along with some other things, so I didn't publish it. Oh well. All right, what else? That was 5. What else? 6. So 6 gets confusing because you've got so many, I'll say, iterations of difference of squares here. Right. All right, guys, remember we got a lot of people in here, so I need you to pay attention. If everybody talks even quietly, it creates quite a distraction. All right, so first thing I'm going to do is factor, and I'm going to write these separate because I'm also going to go ahead and change this to multiplication and flip it, right? It's going to make my life a lot easier. All right, so I've got up top difference of squares, c minus 1, c plus 1. Does that confuse anybody? All right, bottom. C squared minus 1, C squared plus 1, times, and I'm going to flip over, C squared plus 1 over C plus 1. Now, could I technically start canceling out? Sure, I could, but we're not done factoring. So, yeah. Every division, always change division to multiplication. So you always change it to multiplication and then flip the fraction that follows it. Yep, keep, change, flip. There you go. And go ahead, Paris, what? That's what you keep the first one, change the sign to multiplication, and flip the second. Keep, change, flip. All right. All right, I'm going to go ahead just because I can. I'm going to go ahead and cancel those out just to show you, just so I've got a little less to write. So right now I'm down to C minus 1, and I was helping a couple of you yesterday, and you went, okay, I'm done. And I said, well, there's something else you could do. That C squared minus 1 is a difference of 2 squares on its own, again, right? So it's a double difference of squares. You could have done it in the beginning. You could do it now. It doesn't matter. I'm going to go ahead, C minus 1 plus 1. That's right, those cancel. So what happens if everything from the top is gone? You put a 1 up top, so I get 1 over. Can I just cancel the 1s out? No, why? Non-parentheses, we're not in the business of killing kittens in here, so no. 7's the one. Is it a doozy? Tell me what you think that's for.
Spray painting.
Yes. Will it confuse anybody if I go ahead and flip this? No. I just want to. All right. So we start. The key to these, even though they look like a lot, take them step by step. Take them piece by piece. Don't make it harder than what it is, okay? So in other words, let's look at the top of the first one. Take an M out first, right? What's left when you take that M out? The bottom here. I'm going to have to, this is going to be a slashing problem, right? So I'm going to come off to the side maybe. What multiplies to negative 30m squared but adds to negative 7m? Yes? So I've got 2m squared minus 10m plus 3m minus 50. What's left? Middle sign stays. What can I take out? 3. Which means this factors as m minus 5. That's right. I got a difference of 2 squares. Perfect. For what? For m. 4m leaves me with 2m. Whoa, get off of there. Is anybody confused? A lot going on, but are you laughing at my assistant up here? Straight across.
I'm a good assistant.
All right, m minus 5s. Tyler says the m minus 5s. 2m plus 3. Now look, there's another one here. Don't get all willy-nilly with your canceling, right, Rhett? We don't want to cancel them all out.
Oh,
we only
boy.
want to cancel out what can. I can cancel an m. All right, so what do I have left? I have an m plus 5 up top. That's all you can do.
Brett, way to get quiet like a good boy. That's
How'd I cancel out what?
good boy.
The m. It is connected, but 4m is the same thing as 4 times m, and so they can cancel as long as they're. So it was this m up top, and then this m right here.
Oh.
And you can cancel those, yeah. Yeah, think about it. It's the same as m over 4m, so if it looked like that, it's a little easier to see that it would cancel. Yeah. So, right, if it was 4, if I had 2 up top and 2 in the bottom, I could, but you can only cancel 1 for 1. So I canceled 1 for 1 here, this one and this one. That one was still there. Yeah.
Is this really best selling?
Brother. Okay. Other questions? Well, that was everything, so we shouldn't have questions. Y'all ready to move on then? Y'all need to stretch a second. Y'all okay? Don't.
You have to have like denominators.
You have to have
Yep, that's right. That's right.
a common denominator. And once you have that common denominator, then you combine the numerators and you put them over that common denominator. Agree or disagree? So we only add the top or subtract the top by Logan, but we keep that common denominator there. Yes, do we all agree? All right. Let's start easy. Okay. Yeah. They staked their seat claims to their seats in third block. Wait, what? 34 people, yes. And I told them the first ones in got the seat, like if first come first serve. I didn't assign them seats because I don't know them yet, and there's so many. Well, but I feel so bad because like some of these desks, y'all, that's like those are terrible places. Because I can get to everybody through the rows and stuff to help everybody and stuff. I don't know. That's foul. But anyway, they didn't want somebody to come in if they beat them to class today. All right. Harris, you caught up? How do I find, thank you, Addison. How do I find a common denominator? Okay. Okay, common multiples is what I'm really looking for, right? I'm looking for a least common multiple. So yes, you could just multiply them together, but it might be too big, right? That number might be too big, and then you might end up having to like simplify it down in the end. So what I always tell kids is, what are the multiples of 3? 3, 6, and so on, right? Da, 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 da. What are the multiples of 4? 4, 8. We're done. We don't need any more because the least one, the smallest one they have in common is 12, right? So if I need the bottom of each fraction to be 12, what do I multiply the first one by? 4. If I do it to the bottom, I have to also do it to the top. Same thing. Remember, we're starting with these easy examples, so don't let it fool you. How do I make 4 become 12? I multiply it by 3, and I do the same thing over here, right? So I get 8 over 12 plus 3 over 12. Everybody knows how to do that, yes? What if I start throwing some variables in? For example, I'll start easy. What if I need to subtract those? What'd I do? What? Who? Rhett? Rhett. All right. What do? I need a least common denominator. How am I going to do that? Well, since they both have a W, I'm going to ignore them right now because they already have them. So I'm going to look at it as 4 and 5 is what I'm going to essentially do. Yes. I'm going to say that my least common denominator for these two is going to be 20 W. Would you all agree with that? Yeah. So I'm going to give this first one a 5, and I'm going to give this second one a 4, right? So I get 15 over 20W minus 8, which would just be, and then I would look to see if I could simplify, right? Which I can't, so I stop. So that's pretty easy when it looks like that. But what happens if the bottoms are not quite so easy to do? Let me show you what I'm talking about. Now, I'm going to tell you my technique of finding a common denominator. I'm sorry. Is it? I don't know. I'm just all over the place. Maybe I should, like, each day I should just go down in a row.
Yeah, you're going like yeah, you can like that.
Am I? Is it everywhere?
Yeah. No, you're kind of in a row. It's going like this. Yeah, it's it's nice.
Yeah. Wait till the end of the unit, and you'll be like, I'm gonna just keep going. Okay, let's keep going sideways. All right, let's say I have something like now I'm going to start, I am going to preface this by saying always factor first. Always, 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 always. That should be, if you're doing anything with any type of rational, always try to factor first. It's going to make your life easier, okay? All right. That's exactly right. R squared minus 25 is a difference of squares. So I could actually write this as why was that convenient? So my problem now becomes, what's my first fraction look like now? Okay, this is nice. Why? They have the same denominator. I don't have to force them to have the same denominator. They already have the same denominator. Yeah. Yep, you can. Not if it's on the other fraction, no. Just in the same fraction. Okay. Yeah, I'm fixing to get to the harder one. All right, here we go. I went easy on you because I'm still showing you. Okay, so you already recognize the difference of squares before we start, right? You go, oh my gosh, I see it. It's a difference of squares. Okay, so that's an easy factor for us. I hope for most of us anyway, or for all of us. But, geez, nothing cancels, right? Nothing else factors and nothing cancels. That's okay. That's okay. So I'm going to rewrite my problem. 5a plus 6 over a minus 2, a plus 2, minus 1 over a plus 2. I'm going to have to make them look the same. Okay? The bottoms must match. What can I do to make them match? I'm going to multiply by a minus 2. You're exactly right. But look, here's what I want to do. I want you, because this is an easy one to see, I'm going to come over to the side and I'm going to show you how I come up with a least common denominator. Or a least common multiple. It's the same thing, right? Remember, factored form is just multiplied form. I'm multiplying things together, yes? All right. So here's what I always do. Everything's got to be in factored form for this to work. I start by writing the first denominator. What's the first denominator? A minus 2, a plus 2. Then I go to the next one, okay, and I give it anything it's missing. In this case, it's not missing anything, right? It's got 1a plus 2 already in there. You agree with that? So I don't need to add anything to it. So I'm done now. This is my LCD. If there was a third fraction, I'd look at that and I'd say it's everything completely included in my LCD already. So now I'm going to force my LCD. This first one's good. What's the second one missing? The a minus 2. So I need to give it an a minus 2. I need to give it an a minus 2. With these subtractions, be very careful about these parentheses, okay? All right, so let me just write it so you see what happens whenever I combine. So I've got 5a plus 6 over a minus 2a plus 2 minus a minus 2 over a minus 2. The order doesn't matter here, as long as they're the same. Everybody okay? Combine the numerators. 5a plus 6 minus, now make sure you put this in parentheses, otherwise you're only going to end up subtracting the a in front and not the whole top. So minus a minus 2 over, still got that same LCD that keeps following it down. You would be multiplying out. I'm going to do one like that and I'll show you. Yes, I'm fixing to finish. I haven't finished yet. Yeah. So several questions here. What if this wasn't a 1? What if that was a number? Or what if it was even another binomial? I would have to multiply that out and then subtract. And we're going to get into some of those. All right. I cannot start canceling anything yet. Everybody wants to cancel here. I can't cancel this because I would be killing a kitten, right? You see that big minus sign that's not inside of parentheses and this plus that's not inside of parentheses? I cannot cancel yet. So, yes, I'm going to combine this top. I'm going to say 5a plus 6 minus a plus 2. Is that what you're talking about? So before I can get everything in parentheses, I first have to make it a lot longer before I can squish it back down. Like terms, 4a plus 8 over not yet. Oh, what did you see that I could do? Take out the 4. Sometimes it's going to help, sometimes it's not. But now I'm back to what we did yesterday with simplifying the rationals, right? Take the 4 out. It leaves me a plus 2. Oh, you see it now? Those are gone, right? So my final answer here, 4 over a minus 2. Easy?
All that for one problem back.
Just wait. Let's do another. Let's kick it up a notch. Who has a question? What's wrong? What's wrong? A plus 2. When? Right here.
4a plus 8.
Yeah, how did you even get that?
5a plus negative 1.
5a minus a is 4a.
Wait, I do got a question.
Yeah.
How'd you, it was a minus 2, but then we changed it to a plus.
Because it was subtracting. So what I did was I took that negative and I distributed through here. What else? I'm glad y'all are speaking up because I want to know where y'all get lost in it. Yes, no, maybe so? Yes, ma'am. Okay. Are you angry today? Are you angry today? Are you angry? You could, because when you're multiplying like something times something, and we just made it one big fraction, and so we could cancel top and bottom there. We can't do that. You can't do it until every plus or minus is enclosed inside parentheses. That's your key. All right, here we go. Try and find me. Is that what it feels like? I can make it where it tracks with me.
Do that.
Okay, I'll find out how to do that. Mr. Hemming told me that you could do that, but I don't. He teaches at Lugoff. Did it just bring everybody to me? What? Oh. Huh? Where you gonna have? You can shortcut it. You can shortcut it. Yeah, by Harris. All right. Let's start by factoring everything because that's always a good place to start, right? Have y'all factored this yet? You can shortcut it. X. Uh-huh. There you go. That's right. What's my LCD for these two? Write the first one. Now look at the second one. It's got an x minus 4. Does it have an x minus 3? No, so I got to give it to it. If it needed something else, I would give it to it there, okay? When you're done, every denominator should be completely included in the LCD. No repeats, though. What multiplies to 12x squared but adds to negative 7? 4 and 3. Negative, yeah. Negative 4, negative 3. All right. First fraction, what's it missing? Now, remember, I have to, even though these denominators are completely the same now, right? I can combine these tops, but what happens is I have this big old minus sign that's not in the middle of a parenthesis. So I cannot just start crossing things out. Don't cross out too early. That's where you're going to mess up. Thank you. Right? Yep. Right. It's okay.
So you can only print it into one if they have
The same denominator.
Oh, so she's still gonna multiply.
Yep. Yep. I haven't done it yet. Did I skip too much there? Is everybody with me? You're so far back, Miles. Huh? Okay, so I'm going to do both. Look, for this one, I could distribute the negative and that's fine, but I'm still going to have stuff outside of parentheses, right? So what I have to do is I have to expand everything. So I'm going to have to FOIL these and distribute because of this minus right here that's not in parentheses, okay? And I'm going to have to distribute this negative sign here. Then I'm going to have to combine like terms, and then I'm going to have to try to factor, okay? So a lot of steps left. Yeah. Yeah. We're going to do that here. We're fixing to. We're going to do the same thing. Yep. All right, I'm going to FOIL first here, okay? Yep. Take the first term and distribute to everything in the second parentheses. So x times x is, yep, x times -3, 1 times x, 1 times -3. And I'm going to go ahead and distribute this minus. Minus x plus 1. This one. No parentheses now. Now, whenever you have these minuses and pluses that aren't inside the parentheses, you have to eliminate all the parentheses first before you can get more parentheses. All right. We're going to gather up together what goes together. X squared. He's all by himself. All by myself. No, I'm just kidding. Okay. Thank y'all. I appreciate that. I really do. -3x, x, and -x. Whoa, not one.
Bro, his name is Nick. How'd you get that? Oh, okay. Oh, okay, okay.
Oh, so -4 and then it goes back to -3.
Yeah.
Okay.
Oh.
Okay.
All right. All right.
What you got? The -3 combined with the 1 to make -2. All right, several of you have seen it already and you went, oh my gosh, we have to factor again. It is the shortcut. It's the shortcut because there's a 1 in front, right? So -2x squared, what multiplies to -2x squared but adds to -3x? All right, let me see what y'all said. What'd you say? -2, -1. That multiplies to +2, so that doesn't work. It's a CBF up top. So I'm done. Cannot be factored. But you do have to always check. Cannot be factored.
Tell us about that.
All right. If you understand and you don't have a problem, feel free to start on your homework. We're going through number 13. If you need a little more help, I'm going to work through 1 or 2 more on the board. All right. Yeah. Over here on my desk. All right, look at this one real quick. This one's not on your homework. I don't want to do any of the ones on your homework because you only have 6. And I want you to have the practice.
At least do like 13. Can you do one like 13?
Yes, yes. If you factor number 13, it's not as bad as you think it is. I'm not a state. What's the LCD here? Because everything's factored. I can't factor. Write the first one. What's missing? So the first one needs what? And the second one needs? See how it's the same thing like with that 4 and that 3 in the very beginning where we just multiplied them by that denominator? That always works. It's just kind of messy sometimes if it's not the LCD. It's just common denominator. But anyway, I digress. Yeah. All right, I'm going to go ahead and multiply. Maybe. Hold on, let me finish this and then I'll help you. All right. So I'm going to go ahead and distribute through, okay? So 3x minus 1 minus 2x plus 6. And if I go ahead and put them over the same denominator as anybody could see. Okay, where did I lose you? Right. So as soon as you make them look the same, which is where I gave them in the top and bottom what they were missing from this. Because think about how you add and subtract fractions, right? If I had 3 over 5 plus 1 over 5, I would make that 3 plus 1 over 5. I'd leave the bottom alone. Yeah. Multiply, we're straight across, but add and subtract, we just leave that denominator alone and just add the tops. All right, let's distribute through. 3x minus 3. Now be careful because really what I'm distributing through here is a negative 2. Because, all right, look, it's subtracting, right?
Yeah.
So I'm having to subtract all of this. So you can do it in parentheses like that, or I would prefer just to do this. Same change, right? That way I'm distributing negative 2. So minus 2x minus 12. Like terms. What's a like in the top? So 3x minus 2x is just x. What's negative 3 minus 12? Negative 50. I check to see if I can factor anything when I get to this point, but I can't. Nothing cancels, and so I'm done. Negative 3 and negative 12. Let me ask you this while I still have you for just a second. What's the LCD?
Wait.
Somebody said it, what? X plus 4. Because that one is over 1. That's exactly right. That usually throws everybody. So the second one needs an X plus 4 before you can. Yep. So you got to give it to both. So you got to give X plus 4. X plus 4.